Dear AS and A-level students for mechanics, hi everyone, and as always, I wish you the best. We are today, my dear students everywhere, in the second part of moments. In the first part, we starting by identifying moments and solve basic problems. Today, our work is with uniform bodies, equilibrium problems. Our main work today is when we have hard or solid, rigid bodies resting in equilibrium. So we may have forces, more than one force acting on this body. We'll apply the fact, this is the main idea for today only, that the resultant force or the sum of the forces on the body are equal, are at the end, the sum of them is 0, and the same for moments. The sum of moments at any given point or chosen point, you will see this in the examples, is 0 as well. We mean by uniform bodies, dear students, that the weight of the body is in the middle, the center of mass is in the middle of the body, exactly in the middle. When it's non-uniform, which is the next lesson, which is the last lesson in moments before we do past paper problems, it will not be, the center of mass is not in the middle of the body. This will come later after this lesson. Our main certain steps, dear students, in every question will be constructing two equations. Equation for equating the forces, equation of forces, and the other equation of the moments. And the main idea will be equating the forces upwards equals to the forces downwards, and the moments anti-clockwise is equal to the moments clockwise. This is the meaning by the sum of them is 0. We'll be explaining now in the examples, and read the notes. Don't only depend on what I'm saying. Read the notes and relate what's written to how to do the questions. Example number 1. First example to explain what were you saying. Straightforward, easy question, the first one. Question says, uniform rod of length 4 meters. So you draw the rod like this, line. Of length 4 meters. And weight 20 newtons. Is suspended horizontally by 2 vertical strings attached at A and B. So this is A here and B here, and the question says we have strings here, simple like this, suspended by strings like this. So when we say string, we mean we have tension, like we learned in dynamics and statics. So the tension of the string attached at A, we call it TA. We are familiar with these things. TB. Tension of the string at B is TB. Since he said the weight and the rod is uniform, so we sketch and we draw the weight. It's 20 newtons. And since the length of it, it's 4, so this is 2 meters. And from here the same, 2 meters. Simple like this. I choose to do the question together, then I did the next questions to save time, but the first one I'll do it together to show you how to draw the question and how to sketch each part. A particle of weight 10 newtons is attached to the rod at point C, where AC is 1.5 meters. New point. So this is 2 meters from here to the middle. It's 2, so C is here almost. we have weight here of 10 newtons, and it is 1.5 meter apart from A. So this is AC. Point C is here. The distance between A and C is 1.5 meters. The question wants find the magnitudes of the tensions in the strings. As we said, let's apply now. What did we say? First step, the equation of forces. The equation of forces. What do you mean by equation of forces? We have forces upwards. I'll do another color to help you, which are the tensions, and we have downwards, which are the weights that he told us. So what do you mean by the equations or the sum is zero? The forces, dear students, upwards are equal to forces downwards. Equation upwards, the forces upwards are in the same direction. Tension at A, tension at B. Forces downwards are the 10 newtons and the 20 newtons. This equation number one. What do you do? What do you get? So tension at A plus tension at B is equal to 30 newtons. From this step, you will understand that because this is one equation with two unknowns, so we need another one, which is equation 2. We are free, dear students, to choose to take the moments about. It depends on us. If the question mainly straightforward, we prefer most of times to take the moments about one of the ends of the beam or of the rod or whatever it is. So step 2, by taking the moments, by taking the moments, again I will say it, we are free about A. If you take it at B is okay, at C is okay, and at the middle of the rod is okay. But sometimes the question will guide us by the information given about which point or what point you'll be taking the moment about. So instead of writing this every time, we do this only. This means taking the moment at A. So we have at A here. So we have two types of moments, two different directions. So remember from the previous lesson, come to each force like this. This force A is here. A is here, look. So do small arrow like this to show yourself from each force. So we have, what do you do now? Clockwise moments. Clockwise is equal to anti-clockwise. Simple like this. What's the moment clockwise? Only TB in this question. TB is clockwise about A. Yes? So TB, force, times the distance from the force, and remember this all 90 degrees of course must be signed, is 4, which is the length of the rod, times 4 is equal to, we have two forces, the moments of them is anti-clockwise. First one is 10 newtons, 10 newtons, and he told us it's 1.5 meters from A, so it's 10 times 1.45 plus the 20, which is the weight of the rod, times the distance. Since uniform, for it's in the middle, it's 4 So the distance is 2. Simply from this equation, some of you are wondering now, sir, the TA didn't appear. Focus will here. Remark. I will write this. I will not be only saying it. TA is 0. The moment, let me write this fully. The moment, dear students, the moment and engineers, the moment of TA, tension in the string at A, about A is 0 in this question. Why? Because we took the moment, this is A. Yes? And this is TA in the question. So what's the equation? Take the moment at A, this is TA, and this is A, yes? The angle is 0, theta is 0 between the force about the point. So when you write the moment here, it will be TA times the distance, sine 0. Sine 0 is 0. Simple like this. Always, in simple words, the moment of the force at the same point is always 0 because the angle is 0. The angle is 0. So only you will get one equation, only for one unknown, which is tension at B. So 4 TB is equal to 15 plus 40, which is 55. This will give that tension in the string at B, the first magnitude. It's 55 dividing by 4, which is 13 and 3/4 and 7.75 newtons. To find TA, which is the tension in the other string, since TA plus TB is equal to 30, so TA plus 13.75 is equal to 30, so T is equal to 16.25 newtons. Simple like this. We might be asked, of course, different questions in the exams, like the coming 2 questions for today. So what did we do here quickly? Look what did we do? Equation of forces, equation of moments. We choose the point as we wish in general, unless we are guided in the question which point will be taking about, the moment about. Example 2. Example 2 says, uniform bar AB of length 6 meters and weight 40 newtons is resting in horizontal position on supports at points C and D. Before we proceed reading, draw like I did. So this is the road in black, AB. Its length is 6 meters. Its weight in the middle, 40 newtons. Distances now, we told that we have 2 supports, where AC is 2, so this is C here. It's 2 meters far from A, and AD is 5. AD is 5 here. Since it's the length of it is 6 meters, dear students, and this 40 in the middle 3, so between this, the middle, and D is 2. 2 plus 3 is 5 meters. We can do this, but it will be like writing many things in the exams. We can do this from here A to D, and we do this. Yes? 5 meters. But this is more neat than was before. 3 plus 2 is 5. Good. When a particle of weight 30 newtons is attached to the bar at a point E, new point, different point, and the bar is on the point of tilting about C. Tilting about C. This is common, and many students, they most of times complain about this in the exams. I don't understand. So I did explain this to you in details here. When the particle of 30 newtons is attached to E, we don't know where is E, so we point E like I did. He wants the distance AE. The best way to do these things, sketch AE, show it on the diagram, and name it. Label it with X, with Y, with D, as you wish. As you wish. So AE is X meters. AE is X meters. AC is 2, AD is 5. Now the information is complete. I wrote to you, yes, but what do you mean by tilting? I'll show you here. Before I do the question, when you see tilting, we have two supports. This is 1, this is C, this is D, dear students. This is the meaning of tilting. Tilting means going oblique. This is the mean by skew, oblique, slant. So he said in the question, it's easy, just we have to focus, and it will be on a point or about to be tilting about C. This is the tilting about C. Tilting about C. This is what will happen. Look. It's almost here. C is almost here. And D was here. This is the mean by tilting. This will happen. What will happen here? When the support, dear students, when the support is not on the rod, so there is no force then. Look, RD was here. D, the support, was on the rod, or the rod on it. So when it's tilting like this, it's about to tilt. It's on the point of tilting, like seesaw. Seesaw. If you're some of you familiar with when two people playing on seesaw, this beam, and one goes up and one goes down. When the one is down like this, has force. When this is floating in the air like this, it's far from the pivot or the support. So here there's no force. Because of this, I wrote to you here, since the bar is on the point of tilt about C, so the reaction at the other one, which is D, is 0. So the force at the support D is 0 when the bar is on a point of tilting about the point C. I think this is clear. I did help you. So the first information, when we see the keyword tilting about the given point, I put the other force of the other support 0, always 0. And the second part of solution, dear students, we take the moment at the point of tilting. Now, do we must do this, sir? No, it's not a must, but if we take, sometimes it doesn't work in some questions. But the most important thing, sometimes in mechanics, yes, I have to understand as a mechanics student or engineer in the future, but sometimes I have to do shortcuts and to make the problems less algebraic work. If I do take the moment at other points here, we'll be having many unknowns in the problem, or not be able to do it. So, to save steps of algebra and to be less confusing, first thing, this is a fact, it's always true, and we prefer most of times if he said tilting about a point, take the moments about the point that the bar or the rod or the body is in a point of tilting about. Then just only we apply the moments clockwise equal to the sum of the moments anti-clockwise. We have one force, dear students, I'll show it in different color, which is 40 newtons. Yes? About C. So this will happen. Clockwise. Do you see it? Do this in the exams. And we have force from here. And we have this one. For the 30 newtons anti-clockwise, and for the RD is anti-clockwise. About C. So 40, which is the weight of the rod, times 1 meter from C, because this is 3, it's 6, yes? The weight in the middle, which is 3, AC is 2, so this is 1 meter. 1 meter. Simple like this. So 40 times 1 meter is equal to RD, the distance between RD and C, 2 plus 1, which is 3 meters, plus 30 newtons, which is the newton of the particle at E, times X. But what do you have here times? This is here AC, which is 2. So the distance between 30, look, 30, we call this X, yes? 2 minus X. Again, this is 30 is X. Now we are taking the moment from this point, or of this force about this point. So we need this distance in black, which is 2 minus X. Easy? From here to here is 2, from here to here is X, so this is 2 minus X. Since RD is 0, so this will be 0. They will be getting only 30 times 2 minus X is equal to 40. Dividing by 10 both sides, simplify. 3x equals 6 minus 4, which is 2. So x equals to 2 over 3, 2/3 meter. X equals to, which is AE. He wants AE. It's 2/3 meters. Simple like this. If you think you need help, especially my specific students, I will do more problems, of course, in the next lessons. Because of this, I'm doing variant types of questions. Variant types of questions. Last question for today. A uniform rod AB has length 4 meters and of weight 150 Newton. This is very common, almost very common in the past papers. The rod is in equilibrium in a horizontal position, supported at the point C and D, where AC is 1 meter. Draw. While I'm reading, I'm drawing. I did draw already. 1C. Do right. AB. AC is 1 meter. AD is 2.5 meters, like shown in the diagram. A particle of weight W newtons, unknown, attached to the rod at the point E, where AE is X. He helped us in here. He named it. He labeled it with X. The rod remains in equilibrium, and the magnitude of the reaction at C, there is C here, is now equal to the magnitude of the reaction at D. Part A, based on this information, show that W is equal to 150 over 7 minus 4x. Part B, hence, deduce the range of possible values of x. What is the range of the possible values of x? Alright, I draw everything, but here in this question I helped you. I did. It's from a textbook. It's drawn the diagram, so he draw to you. But of course, he doesn't draw everything, so in the middle, you have to label 150 newtons in the middle. Show the examiner that this is 4, so it's between this and this is 2 meters, since it's uniform. And label and show what does he say, AE is x on the diagram, x meters. Using this information, as we said in the beginning, in this question he said R reaction at C is equal to reaction at D. Don't keep them as they are. If you keep them as they are, you are telling they are different, dear little engineers. So put them equal to R, for example. Write them once. If you write RC and RD in the diagram, it's okay. But he told you they are equal. When they are equal, RC equals RD equals R. So R plus R, don't write RC and RD. If you write RC and RD, you are telling they are like X and Y, two different unknowns. Then you will be stuck. You will not do the question. This is the mistakes the students do in mechanics exams. Not that complicated and hard like the students saying. And focus on these skills and this information, you'll be fine. Alright. So since RC equals RD equals R, first equation is the equation of the forces. Forces upwards, R plus R is equal to 150 plus W. From this you will get 2R equals W plus 150. So R is equal to, directly they will come to your mind as senior or A-level student. We have two unknowns, so you need another equation. From where you get this equation? From the moments. We have to be smart here. Yes, we are free, but he wants AE is X. AE is X. So best to take the moment at A. If you take it at B, it's wrong. No, it's not. We can take it at B, at D, at E, as we wish. But since he wants AE, of course, more sense to take it about the point A. Okay, take the moment about A. This is A, so we have 1, 2, 3, 4. R is here anti-clockwise. This is anti-clockwise, equals to the moments clockwise. R from R to A is 1, so R times 1 meter plus R times 2.5 meters is equal to W, that he said W at E from A is X. Because of this he helped us. If he doesn't say, you have to do this like we did in the previous example. So W times X, to be able to write easy and simple steps, plus 150 newtons in the middle, because it's uniform, times 2, times 2. Now, simple algebra, by substitution, by substituting R in this equation, add 1R plus 2.5R is 3.5R equals WX plus 300. So this implies that 3.5 times R, substitute R here, which is W plus 150 dividing by 2. Now, as of course A-level or AS students, we are good in algebra to make W the subject. But of course we have shorter steps and easier steps. 3.5 W from here plus, by expanding, 525 by cross multiply, this is 2 times Wx plus 600. Now this depends on us as a student. I mean, Why I multiplied by 2 here? We have to be smart. In these questions like C12 or P1 and P2, when the question says show that, dear student, look at the result. What does he want? There is no 3.5, there is 7 here. And we have 3.5 here. Multiply by 2 to get 7. Is that I did. And it will go easy then. So multiply by 2, what you will get? 2 times 3.57 W plus 1050, 4W plus 2200. We have 2 power 2 sides with W. So you collect the terms of W, then you put W common factor, then divide by this, you will get the result. You will get what does he want. Hence, when we say hence, dear students, mean using this. If you are not familiar, some of you are not familiar with this language, hence, by part A, by the previous part, deduce. Hence, deduce. By using part A. Now, from the denominator, this denominator, we know it could not be 0. It could not be 0. We cannot divide by 0. But why I put more than 0, dear students? Because x is a distance in the question. So it could not be negative, so it should be non-zero, non-negative number. Again, denominator could not be 0. So why it's not negative? Because x could not be negative. The smallest value of this distance x is at A. The smallest value of x is 0. Because it's a distance. This is the meaning by a range of possible values of x. It could be 0 and maximum of it, since 4x less than 7, so x less than 7 over 4, so the range x greater than or equal to 0, less than 7 over 4 meters. It's one of the ideas may come in the exams, and they came already many times. They are common questions. There is no that big difference between non-uniform bodies that we are coming to them tomorrow. I hope tomorrow, after tomorrow maximum. Only will be different only in that the weight of the bar or the rod or the beam or the body is not in the middle. Should be using algebra to find the unknowns. And different ideas that I could be explaining in the coming questions. I wish I did introduce this part in best, and I wish you the best like always. Hear from me soon about non-uniform